Looking at quadratic expressions, they can have any number of terms, 1, 2, or 3, such as negative 16t squared by itself, or we could have negative 16t squared plus 25t, or we could have negative 16t squared plus 25t plus 2. Quadratic expressions with two terms are binomials. Just like a bicycle has two tires, binomials have two terms. Bi is a prefix that means two. Quadratic expressions with three terms are called trinomials. Trinomial has three terms. A tricycle has three tires. Tri is a prefix that means three. Triangle has three sides. Anything that you see that starts with tri means that it's going to be three of something. Some quadratic expressions with perfect squares have some special factoring rules. So if we're looking at some special products and factors, the first one would be difference of two squares. This is whenever we have a squared term minus, and it always has to be a minus in the middle, another squared term. That would be if we had a plus b times a minus b. Now it occurred to me that with COVID, we may not know how to handle questions like this, or what we're even doing right now as far as how it relates to what we learned in Algebra 1. So I'd like to show you how we FOIL, or it's kind of like a double distribution. So whenever we're basically working backwards from the FOIL method that you would have learned last year. If you didn't learn it, that's not bad. It's just something that I choose to go over to make sure that we know what this means. FOIL simply means first, outer, inner, and then last. So if we're looking at a set of parentheses like this, then we can take our first terms, which are the ones in the front, and we multiply them by each other. Then we take our outside terms, or outer terms, and multiply those by each other. Then the inner terms, and finally the last terms. Now we're going to walk through it this way, and then I'm going to show you another method which is the same thing, it's just different terminology. So if I start with x plus 6 times x minus 2, I do first x times x. X times x gives us x squared. Then I do outer, which is x times negative 2. Always put the number first, so it's negative 2x. Inner, 6 times x. And last, 6 times negative 2. 6 times negative 2 gives us negative 12. Now in the center here, I have x's, which means that I can combine those two terms. Negative 2x plus 6x. What's 6 minus 2? Just gives us 4x. So we have x squared plus 4x minus 12. That would be our final answer when we FOIL. As I said, I also realized that FOIL can be a little confusing when you're looking at it like that. So let's try it another way. If I had given you 2 times x plus 4, you would know to distribute the 2, right? We're going to do the same thing here. We'll take the x and distribute it to both of these terms. But then we still have this 6 out in front that we have to distribute to both terms. So doing the red part, x times x gives me x squared. X times negative 2 gives me negative 2x. I don't know why I put the parentheses in there. Now I do 6 times x for the blue part. That's a positive 6 times x, so that's plus 6x. Then outer is 6 times negative 2, or negative 12. Combine my like terms in the center, and I get x squared plus 4x minus 12. It's the same thing as the FOIL method. It's just a way to get to it easier. As a matter of fact, we're going through the exact same steps. First, outer, inner, and then last. FOIL's just a good way to remember the process. Let's try another one. X minus 3 times x plus 4. First, this is the first term times the first term, x squared. Outer, the two most outer ones, 4 times x. Inner, minus 3x. And then last, negative 3 times 4, minus 12. Combine our like terms in the center. That's going to give us x squared plus x minus 12. You'll note that if we factored this out, we'd be going just the reverse process. If I have x squared plus x minus 12, I have to ask myself what multiplies to give me negative 12 and adds to give me a positive x in the center. Well, I would break it up in two parentheses, x and x, because this is just an x squared in the front. Then if this is a minus and this is a plus, that tells you that it's going to be a plus and a minus. Then 4 times 3 gives me 12. Since this is a plus, the bigger number goes with the positive. You see that takes me right back to my original problem. So as long as I FOILed right and factored right, I should have the same exact answer. You'll notice that the x plus 4 is in front here and it was in back here. The only difference there is that we can flip the order of multiplication and it doesn't change anything. Like if I did 2 times 6, that's 12, same as 6 times 2 is 12. It's not always going to be as pretty as when we just have x in front, though. We can have actually any coefficient in front of there. I can have 3x times 2x. I'd just treat it the same way. 3 times 2 is 6. X times x is x squared. Outer is 3x times 2. That's 6x. Inner is 5 times 2, which is 10x. And last is 5 times 2, which is 10. Gives me 6x squared plus 16x plus 10. And that's my final answer. Okay, this takes us to a new type of problem. In this case, we have 4x squared equals 25. Now, if we're trying to find the roots, every time we're trying to find the roots, we want to do the same thing. We want to get everything on the same side. So let's subtract the 25 over. You don't really want to end up with a negative out in front. So anytime I can avoid that, a negative on the x squared, I'm going to try to avoid that. So I'm going to subtract the 25 over to this side. It gives me 4x squared minus 25 equals 0. So that's my start. Now let's go back to the last slide so we can see how we're going to apply the stuff that was in the box to this information. Before we got on our sidetrack of learning how to FOIL and everything and making sure we knew how to FOIL, we had these difference of two squares in the perfect square trinomial. If you look at this, everything in the front has to be a perfect square, and everything in the back has to be a perfect square. Once I see that these are perfect squares, it creates a situation where I automatically know what this is over here. I know that that's going to be a plus b and a minus b. And I'm just multiplying them. Over here, as I look at a perfect square trinomial, if I see that the first term is a perfect square and the last term is a perfect square, I can see if it's perfect square trinomial just by multiplying the two of those, whatever those numbers might be, and multiplying the middle by 2. If this is a plus in the middle, then I know that it just breaks down to a plus b squared. If this is a minus in the middle, it'll break down to a minus b squared. So how does that relate to what we just learned? Here we had 4x squared minus 25. If I look at this first term, can anything squared give me 4? Well, you should probably know that by now. 2 squared is 4. And then I also have an x. So it's x squared, so that's also a perfect square. So I know that my a term is 2x. On the back side, is 25 a perfect square? Yeah, it's 5 times 5. So I know that my b is 5. Now just looking and seeing that this is a perfect square in the front, perfect square in the back, I don't even have to factor or try to figure that out. I automatically know that it's going to follow this formula. This is a difference of two squares, so it's 2x plus 5 times 2x minus 5. And I'm done. I have factored this. I can set that equal to 0 and then solve. Let's go back on the other page. So this gave me 2x plus 5 and 2x minus 5. Just by checking this front term and seeing if it's a perfect square and the back term, I can do this easier. That's equal to 0. So I set both of those equal to 0. 2x plus 5 equals 0. 2x minus 5 equals 0. Subtract the 5 over. Gives me 2x equals negative 5. Divide by 2. Gives me x equals negative 5 over 2. On this one, add the 5 over. That gives me 2x equals 5. Divide by 2. I get x equals 5 over 2. That is ugly. These are my two answers. If I plugged either one of these in to the original equation, we get 4 times 5 over 2 squared equals 25. What's 5 squared? 25. What's 2 squared? 4. So this would be 4 times 25 over 4 equals 25. Now I can multiply straight across. 4 times 25 is 100. 100 divided by 4 is 25. But I can also cancel. 4 divided by 4 just gives me 1. It leaves me with 25 equals 25. That's true, so I know that's a root. If I check negative 5 over 2 squared, it's the same thing. When I square a negative times a negative is a positive. So that would give me 25 over 4 again, times 4 equals 25. The 4's are going to cancel. 25 equals 25. Let's try another one. This is going to be a trinomial, which can already tell me that it's not going to be difference of two squares, because it's only a binomial if it's not difference of two squares. But this could be a perfect square trinomial. Now you'll notice that I have a number in front of my x squared. And the problem split up on two sides of the equal sign. So the first thing I want to do is rewrite it in standard form. That means I'm going to get everything over to my left side. 18x squared. How would I get the 48x over? I would have to subtract it because that's a positive 48x. How would I get the negative 32 over? I would have to add it over to the other side of the equal sign. So now it's in standard form. And now I should see if there's anything I can pull out of each of these. As you can see here, GCF is 2. Our greatest common factor being 2. That means I can divide it, each of these, by 2. So I can pull a 2 out first. That gives me 9x squared minus 24x plus 16. Now once I have the 2 out in front here, because it's by itself, there's no variable out there with it, I can just divide by 2 on both sides. That's going to cancel my 2 out. 0 divided by 2 is still 0. So it's 9x squared minus 24x plus 16 equals 0. Now, I can check my front term. Is 9 a perfect square? Can anything times itself equal 9? Well, of course. 9 is 3 squared. X squared is x squared. So I have 3x as my a. Check the back number. 16 is a perfect square because it's 4 squared. So b equals 4. Now there's a middle term, so I know it's not going to be a difference of 2 squares. But if I multiply these together, 3 times 4, that's 12. Multiply it by 2, I get 24. That tells me that it's going to be my other option here with the perfect square trinomial. So once I see that, all I have to do is take whatever my a is, minus the b, and then square it. I said a is 3x, b is 4. It's 3x minus 4 squared. That still equals 0. What this is essentially saying is that these are the same thing twice. So when I solve this now, I only have to do it one time. 3x minus 4 equals 0. Add the 4 over, gives me 3x equals 4. Divide by 3, x equals 4 over 3. And that's my final answer. The crucial step here is making sure that I can't divide anything by 2 to start with. If I had just left it in this form without dividing by the 2, it would create a problem for me. I wouldn't be able to do this question. My answers would get real ugly. So you need to make sure that there's no GCF. There's nothing I can pull out of here first. No number or even variable that can be pulled out of each of these 3 terms. If you can do that, if you can pull a number out of it, if you can't do that, then you're good to factor. If you can do that, you have to do it then. Pull the 2 out in front and make sure that you can factor this. Additionally, what if I don't realize that this is a perfect square and this is a perfect square? You might think that that'll create a problem for you. But if we just factor this, normally, we can still do it. 9x squared is the same as 3x times 3x. Then what multiplies to give me 16? That could be a 4 and a 4 or an 8 and a 2. We have a minus and a plus. That tells me this is minus and minus. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. If I combine those two, that gives me negative 24x. If I'd done 8 and 2, then 3 times negative 8 gives me negative 24x. Inside would be negative 6x. Now I have negative 30x, which is not the same as the original problem. So I would know that this is wrong. Okay, a little long today. I apologize for that. We will pick up here tomorrow, do a lot more examples of these. I talked about our quiz being today or tomorrow. I don't think I'm going to do that. I think we're going to get a lot of practice on these. So we're looking at maybe Wednesday or Thursday, most likely Thursday. All right, guys, have a good day.